Hey guys, after taking the power measurements of the entire monthly reading of my home lab, I was just interested to do a research, and this is what I was working since morning, and I thought let me shoot a video in the night so that I can give the overall conclusion of my research. I want to do a research in a way that I can replace my full-fledged high-end desktop with a mini PC for most of the computational needs, as well as occasional software development, as well as kernel development, and it may not include something like kernel compilation, but as long as you are doing any web based components, doing any designing any web based components, and as well as doing basic user space C programming, and in case if you are writing any C based system software daemons and stuff like that, as I do with most of my open source projects, I want a reliable system, and there are few cases I can't use my laptops for this purpose, because I have both the laptops assigned for a specific task, and I use one of my high-end laptop for any testing of my Toffee and Toffee Mocha software, and sometimes I install in them, and sometimes I do some kind of stress testing and stuff like that. So I have a different role for these laptops, and also I want to figure out what can be the difference between a laptop and a platform like Intel Compute chip or Intel NUC, and as well as these days you get mini PCs in the market. So this is my research overall, and also I want to investigate what if there is a case where we can almost use Raspberry Pi for most of the computational needs, and that may include basic browsing and even occasional software development, and even any kernel development and things like that. So I'm a person who do not play games in my PC, so it is completely overruled. So in case if you are into hardcore gaming, and obviously this is not something for you, so this is a case where you use most of your times a platform like Linux based systems, and it can be partially you may be using them as your everyday use systems, as well as your lab systems actually. So that's what is my research. So let me show my setup. What I have done is, let me just show it to the camera. So as you can see here, below is my Core i7 system, and above it I have used this mini PC, which I have purchased this for building a prototype WAN optimization device with Toffee, and earlier with Toffee Squeezer. So in that case it is perfectly fine because it has dual NIC cards and stuff like that, but apart from using them as a occasional testing device, I am not much using it, and I found quite interesting, why not I use this as my regular PC, and it has enough juice in the CPU so that you can use it as a regular CPU, and sometimes it is much better to use as a full-time PC, and it consumes way less power than a laptop in most cases. And I have just installed a couple of 5-volt spare fans, which I have salvaged them from some sort of computer laptop stand. So hope you can see it on the top. So those are those two fans which I have salvaged, and those are 5-volt fans. So I have connected them to the USB port, and I used some kind of heat glue, hot glue. With that I joined those two fans, and you can just take them apart, and or else you can just keep it on the mini PC. So idea behind the fan is sometimes I may do occasional compilation or any software builds, and as an experiment I want to compile or render this video with this mini PC, and I want to check whether it qualifies for 80% of my regular workloads, and apart from that, of course, I do video chats with my clients and stuff like that. So I can anyway talk as usual with my headphones in the Skype sessions with my clients in the overseas, and other than that I can use it for just like that for any transactions which I do, banking transactions, and taking backups in the NAS server once I'm done with the code. And occasionally I do take backups of my Toffee website and stuff like that. So I want to do a research as a part of it, and what I did is I have transferred my 128 GB Transcend SSD drive directly from my PC to this mini PC. And anyway, in one of my videos, hopefully you have seen, it has a 32 GB SSD drive, which is mSATA drive, and the 32 GB drive, I'm currently using it in my HP laptop, and the HP laptop is a dedicated test device. So what's the beauty of a laptop versus a mini PC is the laptops can be used sometimes as a complete package if you're using them in your lab, because you don't need to go for any KVM switches, which I used to do quite a while ago, around some 5 years or 6 years back, and it makes your entire lab setup clumsy, and it is very difficult to organize and bulky it makes. So what is the beauty of laptop is you can use laptops for most of your testing purposes, if not can be doable with your VM systems. So in case if you need a real hardware, you can use a laptop, and as you can understand, it has its own touchpad and keyboard and the monitor or screen. So with that, what happens is you have everything bundled in a small package. So that's the beauty of laptops actually. But the other end, in case if you are looking for a little more higher end usage, and you need some more flexibility at the same time, you don't need to shell out the money, and you need some sort of flexibility so that you can buy a computer hardware. After some time you want to upgrade your hardware, and you are looking for some sort of alternate solution other than these laptops, because one can understand once your laptop gets obsolete, it is quite expensive to upgrade, as one can understand. All you can do is buy one more laptop, and in the meanwhile you can upgrade its RAM, you can replace its hard drive with SSD drive and things like that. But majority of your laptop is you can't upgrade and that includes the battery of the laptops, and you can't extend the battery life of laptops. Whereas in this case of this mini PC, I have connected this to my APC UPS, so one can understand this UPS is designed for some 10-15 minutes backup for a huge PC like this, whereas if you connect a mini PC, it is going to give a decent amount of backup time. And only issue with this is the amount of power consumed by this monitor, which is also supposed to be taken into the factor. So last month I have taken down my monthly lab power consumption readings with my kilowatt meter, as you can see here, and I have also taken some couple of videos and did an article in my Toffee website. So as you can see here, it is total units consumed for 19 days is around 31.6 units kilowatt hours, and the average units per day is 1.66 kilowatt hours. And this is not much with the amount of equipments I got, but in the future if I upgrade my lab and if I get more equipment, and in case if I need to go towards any off-grid solutions, and that is what I'm worried about. And it's not about how many units I consume per day, it is also the worrying factor is using PC all the time, and of course I can replace that with my laptop, but as one can understand, since it has been used for some other purpose, I'm just finding out a different alternative. And also I want to experiment what is the role of Intel NUC and all these mini PCs are going to be in the future. Is it something like they are completely going to wash away the PC market, or what is the future is all about? And this is the exact reason I want to do a research, and I want to install this as my full-time computing device for most of the purposes. And what I can do is I'm thinking about just install a hard disk or an SSD in my Core i7 PC, high-end PC, and I can use that as a dedicated kernel build device, because kernel build alone takes a lot of time, and I want to cut short the total time. And strangely, I have even did a kernel compilation of Toffee Mocha in this mini PC, and it took around 4 hours, and I can compare, it took almost similar time duration to compile the entire kernel, just like my Raspberry Pi 2 device. So, and one can wonder how come a Raspberry Pi 2 device takes almost same time as this much better powerful mini PC. The reason is the Raspberry Pi 2 kernel is quite small, and it is not so much bloated like this kernel. This is a general purpose vanilla kernel downloaded from kernel.org, and sometimes I do apply Ubuntu patches, or I download directly the Ubuntu kernel which is pre-patched, and then I use it for Toffee build. But in this case, it is a general purpose Linux kernel, and it took like 4 to 5 hours to compile the entire kernel, so which is quite a long duration, and I don't like doing any sort of RAM build. So I have done some sort of RAM upgrade, and there is some excess RAM in my HP laptop, so I have replaced its 2 GB RAM which it came along, which is PC3 RAM with the PC3L RAM, which is in my HP laptop, because they have installed 2 RAM modules, and I have taken out one of the 4 GB module and replaced it in this mini PC as. So with that, the RAM, I have enough sufficient RAM, as you can see here. As you can see here, it is not using any swap memory, and it is using only the main memory, which is it is currently utilizing around 2.5 GB, and out of this 4 GB. And if I do any kernel compilation, it is going to consume I think almost the entire 4 GB for totally 2 threads. As you can see here, there is no hyper-threading enabled. There are 2 cores in this processor, and it is showing just 2 cores as it is. So with that, yes, it is a limited resource. But the interesting factor is it's a mobile computing platform, and I may later get an Intel NUC, or else if I get some decent sponsorship, I may even buy a high-end Intel NUC. So the idea is all about also to reduce and cut short my entire monthly power consumption. So the idea behind cutting down the power consumption is not about the savings I got with the same. The idea behind it is to get these devices out of the main power supply source and put it on top of any sort of off-grid solar or wind or hybrid based solution. So this is what my research is all about, and hopefully you might have seen in one of my videos I also work and do some research on satellite technology. So and these are the areas you need to really bother about the power consumption, the total amount of work done with respect to what is the power consumption for the amount of work which is being obtained from a device as well. So with the kilowatt meter which I got here, as you can see here, with this I have taken down various measurements of my Intel Core i7 5820K high-end PC, and as you can see here, for an ideal system, after the Linux Ubuntu is booted, it takes around 70 watts, and this includes all the internal cooling fans and also the CPU liquid cooling, everything included as such. So this is also I have recorded with the storage, which is the Transcend 128 GB SSD drive. So since it is SSD, of course it is going to consume a bit less power. So despite it consumed around 170 watts on an average in an ideal Linux boot scenario, and in the system BIOS mode it is consuming around 90 watts, and when I do kernel compilation with 80% of overall CPU load on all the cores of the Core i7 5820K processor, it consumes around 150 watts, and that is huge amount of power, but it also compiles the entire kernel quite fast. So that's the cool thing about the huge PC I got here. So with the mini PC, I did also taken down these measurements in the morning, and in the ideal system scenario, as you can see here, it consumes around 18 to 20 watts, which is very cool, because with this you can do your every sort of everyday work. So I'm just talking about a person who is into IT software development, and a person like me who almost uses the PC for almost 14 hours a day or 16 hours a day. So I'm talking about a workload something like that. So it is consuming around 18 to 20 watts, and I have seen it is fluctuating nearly sometimes near 17 and most of the times near 18 to 20 watts. So I just mentioned it as a range, and when it is in the system BIOS mode, it is consuming around 16.5 watts, which is quite interesting to note, because the high-end PC, it is consuming little more power consistently, because I have taken these readings around 3-4 samples, and it is consistently consuming around 90 watts, whereas in this case of mini PC, it is consuming just 16.5 watts. And when it is doing any Linux kernel compilation, the mini PC is consuming around 21 to 24 watts, and it is just fluctuating. So I have mentioned as a range, as you can see here. So if you compare here, of course, this is going to consume huge amount of power, but that is what is the device is purchased in the first case. So it is, of course, it is not even my system which is supposed to be returned to my client or my customer. So this is supposed to be a sort of high-end Toffee WAN optimization build. So it's a sort of research device, but on the other hand, it is an excellent device or configuration for any consistent everyday kernel build devices. So I'm talking about in case if you are engaged in a kernel programming or the entire kernel build, and you are supposed to do around 4 or 5 times a day or more than that, you need a system like this with as many cores as possible, and as well as excellent per core performance, not just so many cores, having a processor with so many cores. So you need a system like that. But 90% of your time, in case there are also few days I may never do any kernel compilation, or else I may never do any software development. And in those days, in case if you need a system as an alternate system other than this huge power hungry system, then you need something like this, or else you need a laptop. And of course, I can use a laptop. As I said before, the idea is not about using a laptop. The main reason of finding a mini PC I found, which is a lot more interesting than a traditional laptop, is the laptop, when you buy it, comes with a standard package, and these days they still continue to deliver with traditional hard disk drives, not SSD drives. And other than that, sometimes you may get a lot more RAM than what you need, unless you are some kind of gaming freak, or else there are cases like you may use Windows, and maybe it may consume a lot more RAM. But in case if you are like hardcore Linux guy like me, and if you are using Linux for entirely all your tasks, because I do the entire thing in Linux, there is no Windows system in my home or in my home lab, so there is only Linux here. So in that case, I do even photo editing and as well as video editing in Linux, and I have a lot more Linux based tools to do all these jobs. And for editing my YouTube videos, I use Linux Kdenlive software, and for photos I use GIMP and Color Paint and tools like that. So I use just Linux, and I don't use Windows. So sometimes the RAM they provide in these laptops, especially the high-end laptops, is a lot, which there's like 70% you may never use. So in that case, it is good to have a mini PC, so that you can have a basic system which is a high-end system for a sort of a Linux build especially, and apart from that you have the flexibility to buy a mini PC, of course without any storage drive installed in it, and in that case you can directly buy an SSD drive and start using it with SSD drive rather than paying money for hard drives in a laptop and then taking those hard drives and you don't know what to do with that. And in my case, for example, I'm using many of my laptop hard drives as a NAS drives, and of course one can argue it is not a good idea to use non-NAS drives in a NAS device, but I'm not powering it for 24/7. I'm just I just turn on once in a while and I do a scrub operation once in a while, so in that case it is perfectly fine still. And sometimes even laptop drives are much more durable than a standard 3.5 inch desktop internal drive, so in that case it is still fine, it works for me, and I'm using it from past more than 2 years, and I feel it's a good choice to use these drives instead of tossing them out. Just use it in your NAS backup server. So these are few things which you need to understand. There is a lot of difference between a laptop and a mini PC, and apart from that the battery and the battery backup time. If something goes wrong with the battery after your warranty period, you need to buy a new battery, or else it can be some sort of costly upgrade or costly purchase. So these are few things, it is not so flexible. And other than that, if you don't use much the laptop's monitor or the screen, and you need a huge monitor for most of your development work or something like that, because all my videos I focus not about gaming or not about some generic home computing. I more focus about a sort of software development at home, building a lab at home, and it's all about my research, and it's all about my Toffee project, and it's all about my Linux world. So in that case, if you need to connect a huge monitor all the times and you don't need the laptop monitor and you don't much use its monitor, in that case it's perfect to go with the mini PC. It's not that expensive, and with the price you invest in mini PC, you can imagine end of the day you're buying a high-end laptop and you are cut shorting your expense almost by 1/3. And not only that, your power consumption also is far and way too less in a case of mini PC. And of course high-end mini PCs are going to consume more power than what I have showed here, because this is a basic Intel Celeron 1037U CPU, and I have also noted down its CPU benchmarks. Yeah, as you can see here, the Intel Celeron 1037U is around 945, which is its pass mark single thread score, and you can compare some of the laptop CPUs which I got, and its pass mark benchmark, which is around 1818, and the other one 4500U is 1578. So compared to that, its single thread benchmarks are way too less, and it also have very less CPU cores. But other than that, I have tested since morning, and for video playback and for most of the tasks, the entire experience of using that mini PC is extremely fluid. I don't much see the difference between a mini PC and my high-end 6-core Intel i7 desktop. So that's the difference I feel, and that's what I was interested. And at the end of the month, I want to measure the total power consumption of my home lab with this change. Of course, I have done this installation on 9th of July, so obviously 8 days I have used my the high-end desktop just like last month, whereas from now onwards I'm going to use this mini PC as my everyday essential computer, and I'm going to power on the high-end PC once in a while in case if I need to do any kernel build or occasional kernel builds. I'm going to continue doing it in the mini PC. I'm still okay if it takes 4 hours, because these are like once in a while I need to do some basic compilation of a small minor changes here and there. But every time I do any kernel compilation of my Toffee code, and that's the time it needs more frequent compilation cycles, because Toffee is a huge project. You can't just imagine the scale. So in that case, I may switch to my desktop. Just for compilation, I can connect it with SSH session remote desktop, and I can do those things in the high-end desktop. And once it is compiled, I can download the deb files, and I can test it in my mini PC, or else I can test it directly in my high-end system, and I can verify these changes, and I can do a code commit, and I can take a tarball of its backup and start a new version once again. So in this ways it can be still used, the high-end desktop. But as far as I think the everyday computational needs, and as well as any software editing of these video editing of this YouTube videos with the existing Linux video software editing tools, I believe still this mini PC is going to be useful. No need of using the high-end PC for that purpose also. So that's all guys for this episode. I hope you guys liked watching this video log. In case if you have any questions about building your home lab just like me, you can feel free to post it across in YouTube comments. And in case if you have any suggestions to add towards this video, you can post your ideas and suggestions. Thank you once again for watching this video. Have a nice day. Bye bye.